Hi everybody. Hopefully one of the fastest videos in history. We got a couple slides, we got a couple examples, but we've already covered much of this, all right? We already know what a pyramid is, what a cone is. We already know how to find the surface area of pyramids and cones. And then because of yesterday, we got into volumes. We did volumes of prisms and cylinders. So today we're going to mix and match a little bit and find volumes of pyramids and cones. But we already have some of those ideas down. Now we just got to put those two together. So let's get right into it. Yesterday we learned volumes, base times height for any prism or any cylinder. So real quick review. All right, volume equals base times height. So in this case, we've got bases that are triangles. All right, so we take one of those bases, 1/2 of the base times the height of the triangle. Base is 12, height is 5. There's our 1/2 of base times height, and we multiply it by this 18, which is the height of the prism, and we find the volume there. Same thing with the cylinder. We take the base area, which is now a circle, times the height. So here's the area of the base, pi r squared, times the height of the cylinder, which is 9, and we find our volume. So pretty cool. Base times height works in both of those cases. And now let's talk about pyramids and cones. Almost just as simple. Volume equals 1/3 of the base times the height. Doesn't matter if it's right, doesn't matter if it's oblique, no matter what, you find the area of the base, you multiply it by the height, which once again is the length of the perpendicular distance from the vertex to the base. All right, no matter how it's drawn, okay, could be drawn sideways like here and here, but you're going to find the area of the base. Here it's a circle, here it's a pentagon, here it's a hexagon, here it's a rectangle. Okay, find the area of the base times the height times 1/3, you got your volume. All right. Quick little reminder, we got to figure out what the base is. Again, for a pentagon here, the base is a pentagon, we'd use 1/2 apothem times perimeter. Same here, base is a hexagon, 1/2 apothem times perimeter. Here we got a rectangle that's got a B and a W, 1/3 the base length and the width times the height H. For a cone, 1/3 pi r squared times H. Okay, and I know I'm going quick, but I don't think there's anything there that should really blow us away. 1/3 of the area of the base times the height. Here we got cones, here we got rectangles, here we got polygons. Is there polygonal pyramids and rectangular pyramids and cones. So remember those, 1/3 the base times the height. Couple examples. So we got a right square pyramid, 24-meter base edges, slant height of 13. What's the volume? Pause it, figure it out if you want. Here it comes. First of all, I'm going to start with a picture. There's a picture. Square, base edges are 24, slant height is 13. However, you notice on our formula here, we don't need the slant height. What we need is the height, the altitude height, as represented by the blue line right here. Right? Let me circle that in purple. How about that? That's the height we need, not the slant height. So, how do we go about figuring that one out? Well, we should already be wheels turning. We form a little triangle like this because the altitude is perpendicular to the base. So we have a right triangle. You see the 13 hypotenuse. Now this length here is going to be half of the base because it's a right square pyramid. So therefore the vertex lines up directly over the center of the base. Therefore this is 12. We now solve that triangle using the Pythagorean theorem. Find out the height of the pyramid is 5. Plug that into our formula, 1/3 the base times the height. Base is 24 by 24, height is 5, and we find the volume of the pyramid is 960 meters squared. Pythagorean theorem, remember, come in handy. Okay, Composite or compound figures. All right. So I have a solid gold toothpick. My teeth are very important to me. Solid gold, only thing that will do. All right, here are the dimensions. Now, gold has a density of 19.3 grams per cubic centimeter. How much would my toothpick weigh? Okay, so we need to find the volume. Okay, you notice that grams per cubic centimeter? Well, cubic centimeter is the unit of volume, huh? So let's find the volume. First thing, the center part, we got a cylinder, right? From here to here, that's a cylinder. So let's figure out the volume of the cylinder. Pi r squared h. Plug in 0.25 for the radius, 5 for the height, and we find the volume of the cylinder. Now the two ends, here and here, are both cones, right? So the volume of a cone, 1/3 pi r squared h, 1/3 pi, same radius, height of 2, 0.13 centimeters on each end. Two ends, so we add one end plus the cylinder in the middle plus the other cone on the end, and we find out that my volume of my toothpick is 1.24 cubic centimeters. To find how much it weighs, I'm going to multiply that by 19.3 grams per centimeter cubed, and I'm going to find out that my toothpick weighs 24 grams. Now, just a side note, cost of gold today closed at $1,185.40 per ounce. 24 grams is about 0.85 ounces, which means if I really had a toothpick like this, it'd be worth over $1,000. Heck of a toothpick. Okay, that's it. Talk to y'all later.